Today is the first day of our quadratics unit. We're going to focus on graphing quadratics that are in vertex form. In the next couple days, we'll learn how to graph quadratics that are written in other forms. By the end of this video, you should be able to graph a quadratic function written in vertex form and be able to write the equation in vertex form of a quadratic function when given its graph. Let's take a look at some vocabulary. First, vertex form for a quadratic function is y equals a times x minus h squared plus k, where hk is the vertex and a helps determine the outputs. In other words, vertex form is the AHK format that we learned about in our functions unit. Remember that the graph of a quadratic function is called a parabola, and our new vocabulary word is axis of symmetry. It is the vertical line that is always x equals h that divides the parabola in half. Let's take a look at some examples. The directions say graph each quadratic accurately and state the requested information. Our first equation is y equals negative x minus 1 squared plus 4. So let's first write out our a, h, and k values. Remember that a is the number in front of the parentheses, which is negative 1. X minus h is inside the parentheses, so h is 1. And k is the number at the end of the equation being added or subtracted, so k is 4. We saw on the previous slide that the vertex is always the point hk. So in this case, it's the point 1, 4. The axis of symmetry is always going to be x equals h. So in this case, it is x equals 1. And I want to point out here that you cannot just write 1 for the axis of symmetry. The axis of symmetry is a line, and it needs to be written as the equation of a line. Since it is x equals a number, hopefully you remember hoi vux from Algebra 1. When you have x equals a number, it is a vertical line. That is the vux part of that made-up word. So our axis of symmetry is here at 1. Now let's go ahead and plot the rest of the points for our parabola. If you still need to use the t-chart, that's fine. Hopefully you can get more comfortable with graphing quadratics and you won't have to do that. Remember that you always start from the point hk, which we now know is called the vertex. Usually you go over 1 and up 1, but since a is negative 1, we know that the parabola is going to be upside down. So we're going to go over 1 and down 1. Then we usually go over 2 and up 4, but instead we're going to go down 4 because a is negative 1. And this is as much as I had you graph in the functions unit. But now that we're in the quadratics unit, I'm going to be a little bit pickier. So I want you to fit as many points as possible on the graph. So the next point for the quadratic pattern, you'd go over 3, and then 3 squared is 9. So usually you would go up 9. But since a is negative 1, we're going to go down 9. And that's all we can fit on the graph. Now we can connect the points and draw our parabola. Now remember back to domain and range. Remember that domain is how far left and right the graph goes. So if you look, since there are arrows at both ends, the graph will continue going to the left forever and to the right forever. So you could write the domain as negative infinity to infinity, or as all real numbers, which in set notation is x, such that x is an element of the real numbers. The range is how low and how high the graph goes. So if you look at the graph will keep going down forever, so it will go all the way down to negative infinity, and then the highest it goes is 4 with a bracket because it equals 4 at the vertex. In set notation, this would be y, such that y is less than or equal to 4. Now, the x-intercepts, you'll notice that there are 2 x-intercepts. You have the point -1, 0 and the point 3, 0. You should either write the x-intercepts / solutions, roots, zeros, remember they're all the same thing, as coordinate points, or you could write them as x equals -1 and 3, or you could also write it as the solution set, -1 and 3. Okay? Either one of those formats is acceptable. Do not just write the numbers -1 and 3. The y-intercept, you'll notice, is the point 0, 3. That is the only acceptable format for the y-intercept. Then if we look at increasing and decreasing intervals, remember that for increasing and decreasing intervals, you always start on the left side of the graph and you follow the roller coaster along the graph. So starting on the left, you go up and then you go down. And the vertex is the turning point. Remember that when you write out the increasing and decreasing intervals, that you only write the x values. So it is at 1, which is the axis of symmetry, where it changes from increasing to decreasing. And that will always be the case. The axis of symmetry will always be the turning point. So the graph is increasing from -infinity to 1 and decreasing from 1 to infinity. Last but not least, we have our end behavior. Remember, when you write end behavior, you write as x approaches -infinity, f of x approaches blank, and then you fill in the rest. And as x approaches infinity, f of x approaches blank. The first statement means on the left side, so as you go to the left, are you going up or down? And if you look at the graph, you are going down toward -infinity. The second line means as you go to the right, what's happening? We're going down as well. So that will approach -infinity as well. Make sure that you write both statements. You cannot just write the end behavior for one side of the equation. Let's take a look at the next example. We have y equals 1/2 x plus 3 squared minus 4. So if we write out a, h, and k, remember a is the number in front of the parentheses, which is 1/2. H, you have x minus h in the parentheses, so h is -3. And k is the number at the end, which is -4. The vertex is hk, so -3, -4. The axis of symmetry is always x equals h. Then we can go ahead and graph our function. Since a is 1/2, this might be a little bit more difficult to do in your head, but I encourage you to practice because eventually you will get to the point where you're comfortable not writing out the t-chart. So I'm going to talk through how to do this without the table. Hopefully you know that in the quadratic pattern we go right 1 and up 1. So since a is 1/2, we're only going to go up half as much. So we're going to go up a half. Then usually we go over 2 and up 4, but instead we're only going to go up half that, which is 2. Then we're going to go over 3. 3 squared is 9, so usually we go up 9, but we're only going to go up half that. So we're only going to go up 4 1/2. Then we go over 4. 4 squared is 16, so usually we would go up 16, but since a is 1/2, we're only going to go up half that, which is 8. And that's all we can fit on our graph. So you can connect those points. All right, and there we have our graph. So the domain is going to be -infinity to infinity, or all real numbers. The range, the lowest it goes is -4. The highest it goes is infinity. So the range is -4 to infinity, or y, such that y is greater than or equal to -4. The x-intercepts are a little trickier. You'll notice here that the x-intercepts are going to be decimals. I have not taught you how to find those x-intercepts yet. We'll get to that in a few days. So for right now, I just want you to write that they're decimals. And you can say that they are approximately equal to this x-intercept on the left is about -5.75, and the one on the right is about -0.25. Remember that the squiggly equal sign means approximately equal to. The y-intercept is one of the points that we plotted. So even though it's a decimal, you should still be able to figure it out because you know that when we went over 3, you went up 4.5. So this is the point 0, 0.5. Then for increasing and decreasing intervals, remember that the graph always changes direction at the axis of symmetry, which is -3. And if you start on the left side of the equation and write it like a roller coaster, you go down first, and then you go back up. So it is decreasing first, and then it increases. So it is decreasing from -infinity to -3, and increasing from -3 to infinity. Last but not least, we have our end behavior. So we have as x approaches -infinity, f of x approaches, so if you look on the left side of the graph, it is going up, so it is approaching infinity. And as x approaches positive infinity, which means the right side of the graph, that side is also going up, so that is also approaching infinity. Most of this should be review from our functions unit. It's just we're concentrating on parabolas now. So now let's go back and take a look at how to write the equation from the graph, which we also did in our functions unit. So if you remember, the first thing we need to figure out is a, h, and k, and then we can plug it into our equation. So we know that hk is our vertex, which in this case is 4, -2. A is always the tricky one. To find A, start at the vertex, go to the right one, and see how far up that point is. You can see that this point is up 1/2, which means A is going to be 1/2. Then we can plug this information into our equation. We have y equals A times x minus h squared plus k. So that is the equation of that parabola that's graphed. When we look at the next example, we have a, h, and k. Our vertex is going to give us hk, which is -1, 6. And again, a is the tricky one, but you start at the vertex, go over 1 to the right, and then we have to go down 1 to get to the parabola, which means a is -1. So if we plug that into our equation, we have y equals x minus h, which will be x plus 1 squared plus 6. Hopefully you remember this from our functions unit. Really the only thing that's new is we are calling the vertex and the axis of symmetry the axis of symmetry.